So what we saw last time was a concept where we looked at operator new and delete, and we worked only with primitive data types. Earlier, we also explored the library functions which are available, especially malloc, calloc, and realloc. Those three functions we had seen, along with a function called as free. We understood the difference between malloc, calloc, and realloc, and we also understood what's the role of free. After that, what we did is we went in for operator new and operator delete. And with new and delete, as well as with malloc and calloc, we created single variables. We also went on to create an array. So we worked only with primitive data types. Now it's time for us to work with class type, composite data types. So we'll now see as to how we can handle dynamic memory allocation for composite data type or class types. So the first example that we'll take is we'll start working with a class, and we'll carry out operation to create objects of that particular class dynamically. And we'll see what is the major difference between malloc and calloc, as well as malloc calloc as compared with new. Remember, when we talked about the new and when we talked about malloc and calloc, we said it only allocates memory. It does not actually create variables. It at times can allocate memory which is I say large enough to accommodate anything, but it is not creating any particular type of variable. That is the reason we had to typecast that particular block of memory. Whereas new was actually creating variables. It was actually creating arrays. So that was a major difference. Now I said so, but now we have an opportunity for us to check whether what I said is correct or not. And the way we can check is if objects are created, remember constructors are being called. So if C++ actually goes on to create an object, then if operator new actually goes on to create an object, then constructor should get called. And if malloc and calloc are also creating object, then constructor should get called. And if a constructor does not get called, it is an indication that if a constructor does not get called, it is an indication that only a block of memory which has been allocated, which is large enough to accommodate that object, but object has not been created. So we'll see as to how it actually works. So let's directly jump on for an example that will work with an object that we create. So let's continue. Let me show you a simple class, and then we are going to do certain things with that particular class. Look at this particular class that we have. We have a class called as video. This class video has some attributes. One is length, other is price, and third is year of release. So float takes in 4 bytes, price takes in 4 bytes, year of release takes in 4 bytes. So possibly this will be an object which is exactly of size 12 bytes. Possibly it will be an object which is exactly of size 12 bytes. It has its own constructor. It has a destructor. It has a constructor. Don't ask me for a moment what this virtual stands for. I'll be explaining you as with this particular topic itself why I'll be writing it as virtual. But then it has a destructor. It has a constructor. It also has a parameterized constructor. And then there is a method which will print the details of the video. There is a method which will accept the details of the video. A very simple POJO is what we have. It's a very simple class is what we have. And what I do is, like traditionally what we do, I go on to construct an object. What am I saying over here now? If you watch carefully, what am I saying? I'm saying new video, and I'm calling the parameterized constructor. So when I'm calling this parameterized constructor, so we are going to pass the length of the video, the price of the video, and the year of release of that particular video. So if you look at that, we are constructing object v1. This is the price of the video, the length of the video. This is the price of the video, and this is the year of release. And here we are constructing another object v1. But when I'm constructing object v1, yeah, v2 in this particular style. So in this case, default constructor will get called. So there are parameterized or default. One of these constructors is going to get called. And then I go on to display the contents of the video. So when I say v1.print video details, so v1 video, these are the details. So when I print video details, the length and the price and the year of release should get printed. So let us quickly run this particular part of the code, and then we'll look at dynamic. So there is nothing dynamic that we have done. Here it's a regular code that we have written. We have a class called as video, and we are constructing object of class video, 2 objects of class video, and then we're printing the details. Just to make sure that we are in a position to keep a track whether we visited destructor or the constructor, I have put some message over here. We should rather never add such kind of statements, but here in this example, I'm adding such a statement just to verify whether constructors and destructors are getting called or not. So if any time destructor gets called, this is the message that will get printed. If constructor is getting called, these are the messages that will get printed. So look at this code. We have constructed 2 objects. So obviously 2 constructors have to get called. here the parameterized constructor has to be called, and here the default constructor has to be called, and I'm going to print the details, and after that the program gets over. So 2 times destructor also should get called. So let's run this particular program directly. So as I run this particular program, let's see the result. So the first parameterized constructor got called for v1, default constructor for v2. We have printed the details of that particular v1 movie, and then 2 destructors. Obviously 2 objects have constructed, so 2 objects have got destroyed. So that's all simple, what we already know. So let's comment this particular part of the code. Now this was static creation of an object. That means this v1 and v2 will reside on the stack frame of function main. Remember, we have been talking about that area called as stack, and on the stack we have activation record, that's the stack frame, and on that stack frame we will have this v1 as well as this v2. These are 2 objects which will be present on the stack frame of that particular function. Now we plan to create object dynamically. So this time around what I'm doing is I'm having a pointer to a video. Look at this. I say video star VP. Now when I'm saying video star VP, VP is a pointer which can store address of any object of type video, and that has been initialized to value as null. And I'm allocating some memory. Why do this? I'll rather say size of video. So when I'm saying size of video, whatever is the size of video, we are expecting the size of the video to be 12 bytes. So whatever the size of video, that many bytes of memory will be allocated. A block of memory is allocated. So we are actually not creating object. We are only allocating a block of memory, and this block of memory is going to behave as if it's an object. So we are going to forcefully make it behave as if it's an object. There is no object which is actually being created. So what's the proof of it? If an object is being created, then constructor should get called. So we are just going to keep a track to understand whether constructor gets called or not. And when the object gets destroyed, destructor has to be called. So we'll also keep a track and see whether destructor gets called or not. So we have this pointer. How do we read this? We say VP is a pointer which can store address of any object of type video, and that pointer has been initially set to value as null. We allocate memory which is large enough to accommodate that object. So I'm saying malloc size of video. So when I'm saying malloc size of video, so whatever is the size of video, that many bytes of memory is what we are passing as a parameter to this particular function. It is a number that we have passed. I could have directly passed 12 also if I was very sure that object is only of size 12 bytes. So this memory has been allocated, or rather with malloc only we are making a request for allocation of memory. We cannot be sure whether memory will get allocated or not. We can at the most make a request. So we made a request. Now it is for the OS to check whether there is enough memory on the heap for allocation. If enough memory is available on the heap, then the object will get created. And if the object gets created, its address will be returned. And if OS rejects our request for allocation memory, it will return value as null. So whatever address it is returning, it returns address of type void star. If you look at the syntax of malloc, its return type is void star. So we have casted it as type video star because we intend to treat this block of memory as if it's an object. Actually, malloc has not created an object. It has only created a block of memory, which we are forcefully treating as if it's an object. And VP pointer will now point to that particular block of memory. Actually, VP is a pointer which can store address only of type video. So we have to typecast because malloc is returning void star. Address of type void cannot be stored into pointer to a video. So to pointer to video, we should store only object or address of a video. And if it is successful or not is what we are checking. If VP mein null hai, so we are saying allocation failed and then exit failure. So we are going to check whether allocation is successful or it has failed. If the allocation is successful, I just go here, I say details of the video are as follows, and I'm going to give a call to method called as print video. But before we print the video, let's also accept video details. So to accept the video details, I give a call to a function called as accept video details, and then I'll go ahead. So I say pointers, using pointer, I'm doing that. So I'm saying VP arrow, whenever you use pointer, so we'll have to use this indirection selection operator called as this arrow, which is called as indirection selection operator. So I accept the video details and then I print the video details and then I say free VPTR. And like I always, just to make sure that there is no dangling pointer, this should be set to value as null. So we are going to set this particular thing to value as null. So this is traditionally what we do. Now it makes sense for us to trace this particular code. So let's go ahead. So let's trace this particular code to understand how the behavior is. Okay. So pointer has been created. We say video star, memory has been allocated. We are lucky memory has got allocated. So this function, this condition will be null. We come here, we give a call to a method called as accept video details. I should have printed this message later, but anyway, accept video details. So when we give a call to this particular method, accept video details, control will come to that particular method. Control will come to that method. It will be asking us to accept the details of that particular video and so on. So let's see, control comes over here. It says length. So let's accept the length of the video. So length of the video was suppose 2.3, suppose 2 hours 30 minutes. Forget about what is the value. Then we are trying to accept the price of the video. Price of the video is 555 suppose, and then we want to accept the year of release. Say assume karte hai ki that video was released at some year. Say it was released in the year 1995. That was the release of the video. So we have accepted data into that video class object, and now it's time for us to print the video details. So when I give a call to method called as print video details, we come out, we print the length, the price, the year of release, and we come out. Has all printed. Length of the movie is 2.3, 2 hours 30 minutes. Price is 555. Year of release is 95. Has happened. And then I give a call to free VP. Now when I say free VP, this VP was pointing to an object that was created. VP is on the stack, and the object has been created on the heap, and VP is storing the address of the object which is stored on the heap. Now I say free VP, object has been destroyed. That means that memory has been released. And then I say VP is equal to null. Have you noticed one thing? In this entire case, nowhere constructor was called and nowhere destructor was called. That itself is a good enough proof for us to understand that malloc did not create objects, but we could treat that block of 12 bytes as if it's an object. So when you said over here, size of video, so we are asking the malloc to allocate 12 bytes of memory. So in this case is possibly 12. So in that case, it is allocating a 12 bytes of memory. And once that block of 12 bytes have been allocated, we have typecasted and forcefully treated. By typecasting this, we are forcefully treating it to be a type of video. Actually, there was no video which was created. It was just a 12 bytes of memory, and which we treated by we are saying accept, and which we are saying print detail. We are treating that object of a block of 12 bytes as if it's a video. I could have again typecasted the same block as char star and stored 12 characters also inside it, because it's just a chunk of memory that has been allocated. There is no object which has actually been created, but we are treating that block of memory as if it's an object, because we have stored we have forcefully converted that address into a type video star. Same point I could again convert to char star and treat it as a character or treat it as integers as well. It's totally my choice, because there are just a block of 12 bytes that got allocated, nothing more than that. Now let's do the things slightly in a different way. Let's do it C++ way. Suppose now it's the same pointer VP which is initially set to value as null. It's the same pointer VP which has been set to value as null. Initially which has been set to value as null. Here we go. Now what I'm going to do, I'm going to write the code C++ style now. So there is going to be a change. Same objective I'll try and fulfill, but the code is going to be C++ style. So let's do it and see. So this is the code that we have. Let's format this particular code. So we have this VP, which is nothing but a pointer to a video, which has been initialized to value as null. And I say VP is equal to new video. New video. Okay. So I plan to construct object of type video. So I'm planning to construct object of type video. And then I'm going to give a call to this particular method called as accept and display the details of the video and so on. So I'm going to give a call to method called as accept video details and display video details and so on. So I'm going to carry out that operation. Let's do it the C++ way. So here we go. We start debugging the code once again. Pointer has been created. We say new video. See what's happening over here now. The moment I say new video, moment I'm saying new video, the control has to go somewhere. Where is the control going? Oh. Okay, let's do it once again. Let's put a over here, and let's trace this particular code. I say new video. I said new video. So here, new video, constructor has got called automatically. We did not call the constructor. That itself is a proof that new operator is creating an object. So a video object has now been created. Constructor has got called. Look at the message that is there. Default constructor invoked and so on. And then we give a call to method called as accept, wherein we are accepting the length of the video. Suppose length of the video is 3.3, price of the video is 556, and year of release is suppose 2004. And then we go on to display the details of the video. So I display the details of the video. Watch it. First we accepted the details of the video, and now we have displayed the details of the video and so on. I should rather have put the statement later anyway. But point is, constructor got called, and constructors are called only when the objects are being created. Now later, I no longer require this object. Assume karte hain ki our need of that object is done now. We have done with that particular object. We no longer require that particular object. So I'm going to say delete VP. Now when I say delete, see where the control goes. The control has gone to the destructor. That itself is a proof object was created. New creates object, whereas delete destroys object. So since it has destroyed object, the destructor function has got called, and all the statements that are there in the destructor, which will clear the state of the object, they have got executed, and we proceed further. And we then proceed further. Okay, destructor has been invoked, and we proceed further. And VP is null and so on. So the learning from this particular example was when we used malloc and calloc, no constructor, no destructor. That means no objects are actually being created. Whereas when we are using operator new, it is the object that has been created. Now this time around, what I'll also do is what malloc and calloc could not achieve, because they did not construct objects, so there is no question of initializing them. Now here, what I'm going to do now next, I'm actually going to call parameterized constructors. So I'm saying VP is going to new video, and there are some parameters that I'm trying to pass, and then I'm going to immediately display the data. Let's see whether the parameterized constructor gets called. The point that I'm trying to put across to you all is new creates object. That is what I want you to understand, or that is something that you should carry home today. So I say VP is going to new video. The moment I do that, let's see where the constructor goes. Okay, it has gone to that operator to allocate memory. I should press, let me debug it once again. Debug project. Here we go, new video. So it is allocating that memory. Let me directly run the code for you all. Here we go. Debug the keys. I'm getting problem. Here we go. So we say new video. Watch on the here what has happened. Parameterized constructor has got called. How did this statement come from? Where did it come from? The statement was actually written over here. Here, parameterized constructor got invoked. That means this particular function was executed. This parameterized constructor was actually executed because we had passed parameter. That means we are actually invoking constructor. Here we invoke default constructor, and here what we have invoked is a parameterized constructor. And then we plan to display the details of that particular video. So we want to display the details of the video. So we say the details of the video are as follows. There's a message that we have given to the user, and I say VP print video details. So when I say print video details, these video details are going to get printed one after another. So length of the movie is 150, and then the price and the year, everything has got printed. The price is 555, year is 2018. So this same thing, 150, 555, and 2018, they have got printed. Hold back. I'm going to say delete VP now. Suppose for whatever purpose we have created object, that purpose is done now. We no longer require this object. So I'm going to delete that object. So when I say delete VP, see what happens. Destructor has got called. That's something that I wanted you to understand. So destructor has got called moment the object has got destroyed. So, and then to not to have dangling pointer, so I set that particular thing to value as null. Because I have now moved on to construction of array of objects. Now we have this pointer called as VP. Now what we are going to do? We saw how to construct a single object by invoking default constructor. We saw how to invoke parameterized constructor. Now what we plan to do is we plan to create an array. So I'm going to ask the user how many objects he would really want to create, and so on. But I'm going to destroy it in a different way. Look at this. There is a mistake that I'm going to do intentionally so that we understand. Remember yesterday I told you, if I have an array and if I say delete that pointer P, so it does not delete an entire array. It only deletes the first block of memory. So there are 4 operators actually, not 2 operators. There are 4 operators. There are 2 versions of new operator and 2 versions of delete operator. What we have seen over here is the operator new. Where is this? We saw here operator new and then operator delete. That's one pair of version. The other one is new for creating array, new for deleting an array. So let's go ahead. We have a variable called as number of videos. I ask the user how many video details we would like to store. I ask accept from the user the number of videos, and what am I saying? New video, open bracket, square bracket. So that's another constructor. That's another operator new that we have. Now this operator new is gonna take integer as a parameter. That means it's not gonna create a single object. It's going to create these many number of objects. So whatever is the number of video value that you give, suppose you said 3 videos I would like to have. So in that case, number of video का value 3 आ जाएगा. So 3 video objects ये create करेगा. It will create an array. Yesterday we took array of integers and array of characters. Now we are today looking at array of objects. But keep in mind, had we allocated 12 3 or 36 bytes of memory using malloc, not a single object would have got created. 36 bytes of memory would have got allocated, and we would have to treat that particular block as if it's an array. Here that's not the case. Array is getting created. Again a proof. Now since 3 objects, I assume that I'm going to enter number of videos ka value as 3. Assuming that when I enter number of video ka value as 3, that means if 3 objects gets created, so array is collection of objects in this case. So in that case, if 3 objects have got created, constructor should also get called 3 times. And that is what we'll see, whether 3 constructors gets called. And then we are going to accept the details of the videos. I'm going to say VP of counter, VP pointer of counter. That means VP of 0. That means the first object. Dot accept video details. That means I'm going to accept the details of the first object, and then I'm going to accept the videos of the second object. Note the notation difference. Here I'm saying VP indexing operator I'm using, and here I'm saying indirection selection operator here I'm using. Both the notations are same. Whichever you find comfortable, you can use this particular notation. VP plus counter. Yesterday याद है हमने कहा था 400 plus 1 is 404 for integer. Likewise, VP plus counter. VP is a pointer to video, and these video objects are of type 12 bytes. So whenever I say VP plus counter, that's going to increment by 12 bytes and every time. And same thing I could achieve by using this also, because VP of counter will fetch me value at that particular object address, and that's my object, and object dot video details. And if you find this notation confusing, go ahead with this particular notation. Both will achieve the same thing. What I'm doing is I'm accepting details of all the videos, and then I'm displaying details of all the videos one after another, and then I'm going to say delete VP. This is wrong actually. The statement is wrong, but I'm saying delete VP. Let's see how does it work. So let's run this program directly and see the behavior. I'm directly going to run the program and let's see what is the behavior. It's asked us how many videos you'd like to have. I say there are 3 videos I'd like to have. Have you noticed one very interesting thing? 3 times constructor has got called. That means when we did write this particular statement, when we have written this statement, which statement have we written? New video of 3. That means array of 3 video objects have got created. And since it's collection of objects, and for every object, the constructor has got called. Now I'm going to accept details of the video. The length of the video is suppose 2.5 to 2.3. That's the length of the video, 2.3. And the price of the video is suppose 500. And the release year was 1995. The next movie length is suppose 1.50. And the price of that video is suppose 600. And it was released in the year 2000. And the third video is 2.40, and the price of the video is rupees 700, and it was released in the year 2005. So these are 3 different videos that we have. Note, we went ahead, 3 different videos details have got printed. Let's see, we accepted the details of the 3 videos, 1, 2, 3, okay, till here. And then details of the videos are the first video, the second video, the third video. And note, only one destructor got called, and there is some problem that has happened. So, because we destroyed the object in a wrong way. If I'm saying delete VP, we are actually pointing only to the first, because pointer will point to the first object inside that particular array. Now, since it is pointing to the first object inside the array, since we created an object array of, since we have actually created an array, we should have destroyed an array. But what we are writing over here is we have just said delete VP. Now, moment we said delete VP, the entire array has not got created. VP is a pointer. And since that pointer is pointing to some block of memory, only that first object to which that particular pointer is pointing, only that has got destroyed. The array has not got destroyed. That means from that 3 objects ka array, the first object has got destroyed, and then the program also crashed for some reason. So if I really wanted to destroy the entire array, then what should I have done? I should have put over here square bracket. Had I put this square brackets over here, this will make sure the entire array gets destroyed. So we have a combination of our new and delete functions which are there. If you allocate memory by using operator new, you should release that memory by using operator delete. If you allocate memory by using operator new square bracket, then you should delete the memory by saying delete square bracket VP. Now let's run this particular program and see whether destructor gets called 3 times. Let's cross check that. How many videos? Again, I say 3 videos. The first video length is 1.1. Its price is suppose 1000 rupees. It was released in the year 1991. The second video release is length is 2.2. Its price is suppose 2000. It was released in the year 2001. The third movie ka length is 3.3. Assume karo. The price is suppose 3000, and it was released in the year 2010. Note kijega. No crashing, nothing. Objects, 3 objects were created. Look at this. We accepted the first, second, and third. We have accepted details, and then we displayed details of the 3 videos. And note, 3 destructor has got called. Last time only a single destructor function got called. Now there are 3 destructor functions that have got called. The reason for that is because 3 objects have got destroyed. How did we ensure that 3 objects get destroyed? By correctly writing a statement, delete square bracket VP. When I say delete square bracket VP, then the entire array is getting destroyed. So VP is a pointer which is pointing to an array. And if you want the entire array to be destroyed, this is the version of destructor that we need to call, not the one that we saw earlier. Delete VP will only destroy the first object or the object to which that pointer is pointing, and delete square bracket VP will destroy the array of object to which this particular pointer is pointing to. Let's go to the notes about whatever we have discussed so far, because although we are discussing, it's time we should actually also understand what is that we have actually covered up. Delete and the two versions of delete that I have been talking about. Let's quickly go ahead with this operator new and delete. So operator new creates objects or variable or group of variables. So it is actually creating variables. Your new and delete did not create variables. Keep in mind, your malloc, alloc, realloc did not really create variables. It only allocated memory large enough to accommodate that variable. Real variables or objects were not being created. New actually creates objects or variables. Delete destroys object or variables or array of variables. Okay, using this operator, whatever has been allocated for whichever object you have allocated memory using new, only that can be deleted using delete. It cannot happen that you allocate memory using malloc and release it by using delete. That kind of thing will not happen. Object using created using new operator is allocated memory on the system heap instead of system stack. Any object that we automatically create, that means inside the function main, if I said video v1, so that's an object that we have created. Statically, memory will get allocated. Compiler knows that we want to create that object over there. So in that case, that will reside on the system stack. But when we allocate memory dynamically, that will never be on the system stack. That will always be on the system heap. So memory for this object will get allocated on the heap. Moment an object is created using operator new, constructor of that class is automatically called. Okay, look at that constructor, and the reason for that is, why is the constructor called? Because objects are created, and since objects are created, constructors are bound to get called. Since objects are created, constructors are bound to get called. Likewise, memory allocated by using operator new is occupied by the object until they are not destroyed using delete. That means it is your responsibility as a developer. If you allocate memory, it is you will have to take care of releasing that block of memory. Till the time you do not call method delete, till that time that object will not get destroyed, or it will remain in the memory as long as the program is running. So before the program gets terminated, if you would like to release the memory which has been allocated for the object, it will be your responsibility to call this function called as operator called as delete. Without that, memory will not get released. What does delete do? It releases the memory. When I use the word release memory, that means it sends back the memory to the system heap. And when I say sends back it to the system heap, means what? Whichever memory you had reserved, that reservation is removed. So the system can now utilize that block of memory for any further allocation. So in future, if you're trying to allocate any other block of memory, so that can also happen at this. You are trying to allocate some more memory. This same memory can be reused because you have released it. You are not keeping it reserved for the purpose. Delete not just deallocates memory, but also invokes destructor function for that object. This is important. Delete is not like free. It will only release the memory. No. Before it releases the memory, before it sends that back that memory to the system heap, so that heap can system can utilize that memory, it will call destructor, and destructor can perform the cleanup operation. So the state of the object will be cleared. No footprints of your data will be left in the memory, and then the object will, that area will be sent back to the heap. New and delete offers dynamic storage allocation, similar but superior to standard library function malloc, alloc, realloc, and free. So we saw the standard library functions in detail, but we realized they did not really understand what objects are there. They are alloc memory. They are always returning as void star, and we had to typecast and forcefully treat that block of memory as if it's integer or as if it's a video, and so on. That's not the case with new. When I say new int, it knows it's an integer variable that has been created. If I say new char, it knows it's a character variable that has been created. And if I say new video, it knows it's a video class object that has been created. And remember that example, new round brackets. So it can look like constructor for a new int also. New int round brackets of 44, I'd say. So what's the difference? Video was a user-defined data type. Int and char and float, these are predefined types. They will also have their own constructor. So you can always put parentheses, round brackets in front of them. New operator not just allocates memory equal to the size of the object, but actually creates objects and returns base address of the specified type. So if I say new int, it will return address of type int star. If I say new video, it will return object of type video star. If I say new double, it will return address of type double star, because it is aware that objects are being created. Therefore, no typecasting is required. Since objects are being created, you do not really have to typecast, because objects have been created. And with malloc, alloc, objects were not being created, so we actually had to typecast. And with new, we do not have to typecast because objects are created and appropriate type of memory is being written. Memory allocated using new can be released only and only by using operator delete. So you cannot mismatch. Alloc se allocate kiya or delete se delete kiya, not possible. New se allocate kiya or free se release kiya, not possible. If you allocate by using new, the only way to release that memory is by using delete operator. If new and delete are called for class object and that does not declare operator function, new and delete, they are called for non-class object, the operator new and operator delete is called. Don't worry about this. If you look at our class video that we took, did I define operator a function called as operator new or operator delete inside that particular class video? No. So when we said new video, since we had not specified or given our own version of operator new for that class video, so the one which is globally defined, operator new and operator delete, that are going to get called. That means we also have a chance to give our own operator. That means we can overload this operator, we can supply our own version of operator new, the way you would like to allocate memory. Something will be mesmerized to know operator new in C++ can be overloaded. You can give your own new operator through which you can specify not just how much memory is to be allocated. Okay, you'll feel I'm making a big statement, but that's true. You may not just specify how much memory is to be allocated. You can also specify where that memory is to be allocated. That can also be done. What actually happens is when we are writing programs, a lot of times while we write the programs, we are going to take input from somebody else, or we are going to send output to some other device. And the device, when we have configured, that may have been so configured to read the data from a particular location or to write the data to a particular location. Now, if there was some data that was supposed to come to a particular location, and the device I have configured, the other application I have configured that it can read address from a particular data from a particular address. So if your object does not get stored at that particular location, the other application or other device that is trying to fetch the data from that particular location will fail to find the data at that particular location. So we want a block of memory, our data to be stored at a particular address. So we want our variable to get stored at a particular location only. And that is something that can be achieved by using operator new. Rahul, is that correct? Yeah, it's for interfacing we can use it. Like that block of memory can be used for reading or writing data. So other devices can also interact with that particular block of memory. Since Rahul has given, you should thank Rahul. So now I will also give a demonstration as we proceed with this, how we can create a object at a particular location. That means it is now total control is what we have. We said operator new and delete are very, very powerful. They are sophisticated kind of functions, much better than malloc and calloc. This is the kind of power that we get using operator new and delete, where we have total control over not just how much memory is to be allocated, not just for what type of memory is to be allocated, for what purpose you're going to use that memory. You can also dictate where is that memory to be allocated. But till the time we do not write our own version of operator function, okay, wherein we are dictating where that memory should get created, till that time what is going to happen is these are two global functions which is there, operator new and operator delete. They are getting called. Then all this yesterday and today, last session and this session, whatever examples I took, in all those examples, it was this operator new and this operator delete, the version that you see over here, they were the one which are actually getting called. But then there are a number of versions which are being provided. So the other version that we saw today was this new square bracket kind of thing, the one that we saw today. So you may be wondering, sir, we did not initialize the object. Where did we give a call in this particular fashion? I'll give a demonstration of this. And this is what we have done: delete square bracket, and then we said VP. Okay, that pointer was to be deleted. But how about this? Let me just give a small example how an object can be used and it can also be initialized. If you look at the same example that we are talking about earlier, at the bottom, there was some part which I did not discuss with you. Here, there is a small piece of code that I can actually run for you. And what am I doing? Assume there were objects which are already created. Assume there were some objects which are already created. Let's assume that there are some objects which are already created. And what am I doing? Suppose these are 3 objects which are already created. Okay, V1, that's a default constructor. V2, there is a parameterized constructor. V3 is copy constructor, which has been initialized with another object of its own type. And what am I saying? New video 2. That means I want to have an array of objects, and these 2 objects have been initialized with V1 and V2. So V1 and V2 will be used to initialize those 2 objects which have been created, and then I'm going to print the details. So when I say V1 and V2, V1 में तो garbage रहेगा, और V2 में जो अपने value रखा रहेगा वो आ जाएगा. So this is something that can be done. So we are initializing an array. Not just a single object that has been initialized. We have also initialized an array. This was all garbage. We never know from where it came. Okay, where it came. But this is something that was because of that thing. And 3 constructors because V3 was also created. So this is how the objects were created. Suppose here if I had passed V2, here we have passed V2, and here if I had passed V3. So repeated, both the data would have been same. So it's an array in which 2 objects which are identical which got stored. Watch it. First, and three objects were destroyed. Three objects were created, three objects have been destroyed. Okay, default constructor, parameterized constructor, and you could not see the third constructor because over here copy constructor got called. Point is, it is creating an array. Point is, it's creating an array. So there are two different versions of new and delete. The one that we used for this, and what we have used today is new square bracket, round bracket kind of thing. So this is what we have used now. You can define your own version of new and delete for a class by overloading them. We can declare new and delete operators with additional parameters. And what is that additional parameter that I was talking about? We are talking about the location where we want that object to reside. When new and delete operates on a class object, the class member functions new and delete are called if they have been declared. So if you have provided your own version of new and delete, then the global new delete functions will not get called. There are four global one functions. The new without square bracket, new with square bracket, delete without square bracket, delete with square bracket. So there are four. But if you supply your own new and delete version, in that case, your version of that particular function will get called inside the class. The operator provides dynamic storage allocation. Dynamic because we are allocating memory as and when we want, and we are releasing it also as and when we want, and when we do not want. So we will allocate memory as well as we release the memory. It's total under control. Allocation expression containing new operators used to find storage in free store for objects being created. That means memory will never get allocated on the stack. Free store is your heap. So it's always on the heap that the memory will get allocated. And the allocation is successful, new operator is a function, keep in mind, it is returning an address, but address not of type void star like what malloc and calloc did. It is returning address which is of type of the variable that we are trying to create. Integer, new integer, integer array address, new character, character array address, and so on. Pointed to the object create kiya, to pointed to the object, and can be used to initialize the object. So it's up to you. You can pass parameters and initialize that object as well. And if an array was created, you will get the address of the first object, because base address of the array is nothing but address of the first object inside that particular array. Likewise, if you look at delete operator, it destroys the object created by using operator new by deallocating the memory allocated with that particular object. So if you have created an object using new, you release the memory by using operator delete. If you create an array of object by using new square bracket, then release it by delete square bracket, and so on. So this was the simplest version that we had, delete pointer variable, but this was pointer angular bracket means compulsory. So delete square bracket is delete delete that will just destroy one object. Okay, wherever that pointer is pointing to. The operand of delete must be a pointer returned by new and cannot be a pointer to a constant, and so on. So it has to be the regular pointer to which the address was stored. So when I said VP is equal to new video, so video जो object create हुआ है उसका address अभी VP में stored है. So if I say delete pointer, so that should be that pointer, not a constant pointer. Constant pointer, its value would not have been initialized na, dynamically. So we regular pointer chahiye, cannot be a pointer to a constant. Delete object has a return type void. Delete operator has an return, because it's every operator is a function. So its return type is void because it just releases the memory and does not return us anything. And deleting a null pointer has no effect. So if I had said video VP equal to null, yeah, int star PTR is equal to null, and then I say PTR equal to null, delete PTR, no effect, because null is nothing, it's not pointing anywhere. हाँ, अगर ऐसा हुआ, the PTR is pointing to an integer. Okay, int star PTR is equal to new int. You say delete PTR and again say delete PTR. Deleting a pointer more than once, block of memory more than once, will result into crashing of the system heap. But if the pointer was not pointing anywhere, it was null, you may release it anytime, nothing, no problem, no effect. Delete square bracket, round bracket kind of thing. This operation for an array created with using new. That means if you allocate memory by using this new, then this delete is the version that we'll have to go ahead using. Whereas delete operator, free storage allocated for individual objects created with new. So there are two different versions, new and delete, and new with square bracket and delete with square bracket. So this pair is what we will have to use them in combination only. The result of deleting an array of object with delete is undefined. That means you allocate using this new square bracket, int से आपने allocate किया. Look at this. Here. You allocate by using this and you release by using this. You never know what will happen. Other way around. You allocate by using this and delete by using this. Undefined behavior. We never know what will happen. Okay. Array dimension need not be specified with delete. Yesterday Girish had asked the question, do we need to specify how many objects are there inside that array while deleting? How many variables are not required? The result of attempting to access a deleted object array is undefined. Anything can happen. If a destructor has not been defined in the class, delete invokes destructor, because delete is actually destroying an object. And since objects are being destroyed, destructors have to be called. Destructors are bound to be called. Whether destructor exists or not, delete free storage pointed to by calling the function delete of the class if one exists. What is it? Whenever destructor exists, or whether destructor exists or not, whether you have defined a destructor or you have not defined a destructor, delete frees the storage pointed to by the calling of the function operator delete. So when I say delete PTR, the PTR is pointed to some class object. Whether that class has a destructor or it doesn't have a destructor, the memory will definitely be released. And but if it has a destructor, then the first destructor will get called. That will clean up that particular block of memory and then release the memory, kind of thing. The global operator new only frees storage allocated by using global operator. Delete will only release memory allocated by this new. This is, I'm just trying to put in your head कि ऐसा ही है. And अगर आपने new square bracket से allocate किया है, the only way to release that is by using delete square bracket delete. This is something that you have to keep in mind. Thank you all. So we stop here today and we continue with a further discussion. Next session is again going to be a deep dive into some advanced concepts